A right cylinder has a radius of 4 meters and a height of 2 meters. It is made from a material that has a density of 8 kilograms per cubic meter. What pressure would it exert off the floor beneath it? Okay, so we're working with pressure in this problem, therefore we need to remember the formula for pressure, which is pressure is equal to force over area. But we can derive this formula to be equal to pressure equals, force is the same thing as mass times gravity, so mass times gravity over area. But we can derive this formula again to be pressure equals density times volume times gravity over area, okay? But we can derive this equation again to be equal to pressure is equal to density times area times height times gravity over area. Cool? Cool. Okay. Now we want to plug in the information we know. So we are given a right cylinder, meaning that the area of the right cylinder is going to be equal to pi r squared. Okay, so if we expand this equation, you will then have the pressure is equal to the density times pi r squared times h times g for gravity over area, which is pi r squared. But see how there's a pi r squared here and a pi r squared here? You can just cancel these out. So technically you don't even need the radius because it cancels out. In the end, you're left with pressure is equal to the density times height times gravity, which you know that the density is 8 kilograms per cubic meter, the height is 2 meters, and the gravity is, doesn't say here, but gravity is always 9.8 something something, so we're just gonna assume that it's 10, okay? It depends on if your professor considers gravity as like the more accurate value or just like the general value. In these physics videos, I'm just gonna assume that gravity is 10 for physics 1, okay? So pressure is going to be equal, grab your calculator, 8, this is not 8, 8 times 2 times 10, you have 160. So it would be 160 PA.